Hello Science 30s. This week we will learn about bronsted lowry and acids and bases. First I want to review what you've already learned about acids and bases in previous courses. In previous courses you've learned that acids ionize in solution to produce hydrogen ions. And that'll often take the form of H blank aqueous or blank double OH aqueous. And so that would be your molecular acids. The other thing you learned is that bases are going to dissociate to produce hydroxide ions. And hydroxide ions means that, of course, that it has to be paired with some kind of, in here, cation. And so some kind of cation would be going in there. Now, that definition is fine until you get to some certain chemicals. And the chemicals that we're going to be talking about today, there's just 4 of them that we're talking about, but there's a lot more that do not fit this this definition. And so if we take a look at these 4 chemicals, we have ammonia, we have carbon dioxide, we have aluminum chloride, and we have sodium carbonate. If I was to give you these and I was to say, hey, are these acids or bases? Well, based on Arrhenius's definition, it doesn't look like H blank, and it doesn't look like blank double OH, and it doesn't look like blank OH. And so we would actually predict that all of these would be neutral. But when I give you guys litmus paper and I say, okay, go ahead and test ammonia, it turns out to be a base. And carbon dioxide turns out to be an acid. Aluminum chloride turns out to be an acid, and sodium carbonate is a base. And so this is unexpected, and that means we need a new theory. In 1923, Bronsted and Lowry separately came up with a new acid and base theory to explain the holes in Arrhenius's theory. It's pretty unique in science where you see people who have worked on a problem separately and yet they come to the same conclusion at the same time. And they did not talk to each other, as far as I know, very much at all before they published their ideas. So what they theorized is that acids are actually going to be proton donors and bases are going to be proton acceptors. Now for the purposes of acids and bases, we can say that a proton in this case is going to be equal to the hydrogen ion. This is essentially hydrogen with its electron ripped off. So what I need you guys to do now at this point in the video is make sure that you have this in front of you. You need page 12 of the data booklet. So please pause the video and get your data booklet out if you do not have it. So we're going to jump right in and we're going to try to do a question on this. And the question we're going to try is right here. So we're going to say, write the chemical equation of the reaction between hydrogen sulfide and water. So I have the series of steps here. You guys can write that down on your own. I would suggest you do that, and then we'll go through those steps right now. Step 1 is to locate the 2 substances on the table. So we go back over to the table, and what we're going to do here now is we are going to actually find the 2 substances. Remember, the 2 substances were H2S and water. Now they happen to both be on the left side, but if we take a quick, very close look at this table, we actually see water right there as well, and that's pretty interesting. We'll come back to that. So then step number 2 is to then go and identify the acid. And the acid's always going to be the closest to the top on the left column. So if we go back to our left column then here, and what we see is that H2S is going to then be the acid. H2S will have to be the acid. And that means that H2O is going to be the base. That means we're not going to pay attention to this water. Now we are going to be looking at this water. As soon as we identify, then not always will it be on the left, both of them will be on the left side. Sometimes, most of the time, one will be on the left, one will be on the right. This case, both were on the left, and so we pick H2S to be our acid. And so then we've now identified our acid. So step number 3, write the reactant side of the equation. So our reactant side of the equation is going to be pretty simple. it's going to be, in this case, H2S aqueous, that is our acid, and we are going to be reacting that with H2O liquid, which is our base. Step 4 of this process is to locate the conjugate acid and conjugate base on the table. So we'll go back to the table, and the conjugate acid and the conjugate base are just going to be the other side of the of each of those. And so what we're going to do first of all is we are going to find our base, which is right here, the water, and just on the other side of that we see that we have H3O positive. Now that is going to be the hydronium ion. On the acid part of it right here with H2S, we just go to the other side of that and we find HS negative, which is the hydrogen sulfide ion. And now we're almost done. Now the next step is the last step is to find the conjugates, write the conjugates on the product side of the equation. And so we go back to our table and we then just write these out. And so the first one we'll write out, doesn't matter which one goes first, is going to be the H3O positive aqueous. And then the second one is going to be that hydrogen sulfide ion.